Hello, and welcome to today's lesson on concentration calculations in moles. In today's lesson, we will understand the relationship between number of moles, solution volume, and concentration in moles per decimeter cubed. In our previous lesson, we explored concentration calculations using mass, expressed in grams per cubic decimeter. You already know that concentration is the amount of solute present in a given volume of solvent. Today, we will extend our understanding of concentration to another important unit, moles per cubic decimeter. This unit is often used in chemistry because it directly relates to the number of molecules or atoms in a given volume of solution, which is crucial for understanding chemical reactions. By the end of this lesson, you'll be able to handle concentration calculations using both mass and moles, making your understanding of solution chemistry more comprehensive and versatile. Firstly, concentration of a solution can be expressed in units of moles per decimeter cubed. This means it tells us how many moles of a solute are present in 1 cubic decimeter of the solution. To fully understand how to use this information, we need to focus on a key relationship: the link between concentration, volume of solution, and the number of moles of solute. This relationship is given by the formula C equals N divided by V, where C is the concentration of the solution in moles per decimeter cubed, N is the number of moles in the solute, and V is the volume of the solution in decimeters cubed. Let's break this down with an example. Suppose we dissolve 117 grams of sodium chloride in 5 decimeters cubed of water. What is the concentration of this solution in moles per decimeter cubed? First, we need to find the number of moles of sodium chloride dissolved. The relative atomic mass of sodium chloride equals the mass number of sodium plus the mass number of chlorine. So 23 plus 35.5, which gives us 58.5. Hence, the number of moles of sodium chloride equals mass divided by relative atomic mass, which is 117 divided by 58. That means we have 2 moles of sodium chloride. Now, let's use the triangle. We can see that concentration equals number of moles divided by volume. Then plug in the values into the equation. Concentration equals 2 moles divided by 5 decimeters cubed. So, the concentration of this solution is 0.4 moles per decimeter cubed. By using the formula, you can easily calculate the concentration of any solution given the volume and number of moles of solute. This is a fundamental technique in quantitative chemistry that allows chemists to prepare solutions with precise solute amounts. Let's work through some GCSE level questions to apply our understanding. What is the concentration of a solution if 0.5 moles of sodium chloride is dissolved in 250 centimeters cubed of water? Pause here to give it a go. First, we need to convert the centimeters cubed to decimeters cubed. Since 1,000 centimeters cubed is 1 decimeter cubed, 250 centimeters cubed is 0.25 decimeters cubed. Like the previous example, we know that concentration is number of moles divided by volume, so let's plug in the values. 0.5 divided by 0.25 gives us a concentration of 2 moles per decimeter cubed for this solution of sodium chloride. Let's try another. What's the amount in moles of sodium chloride in 250 centimeters cubed of a 0.5 moles per decimeter cubed solution? First, convert the volume from centimeters cubed to decimeters cubed. Then use the triangle. Covering the N for number of moles, we can see that the number of moles equals the concentration of the solution multiplied by its volume. Let's add in the values. The number of moles is going to be 0.5 times 0.25. So there are 0.125 moles of sodium chloride in this solution. On to the next question. What volume of solution, in centimeters cubed, is needed to dissolve 0.3 moles of sulfuric acid to make a solution with a concentration of 0.6 moles per decimeter cubed? First, use the triangle to see that volume equals number of moles divided by concentration. Then, with the values, that means the volume is 0.3 moles divided by a concentration of 0.6 moles per decimeter cubed. Therefore, The volume is 0.5 decimeters cubed. The question asks for the volume in centimeters cubed, so remembering that 1 decimeter cubed is 1,000 centimeters cubed, 0.5 decimeters cubed is 500 centimeters cubed, which is our final answer. Here's another question. What's the concentration in moles per decimeter cubed of a solution containing 24.5 grams of sulfuric acid in 250 centimeters cubed of solution? First, we need to find the molar mass of sulfuric acid. That means we add the right number of relative atomic masses of each element together. This gives us 98 grams per mole. Now let's convert that mass to moles. We know we have 24.5 grams of sulfuric acid. So let's take that and divide it by the relative atomic mass of 98. We've now worked out that there are 0.25 moles of sulfuric acid in this solution. Now we've got that in moles, we can use the triangle. Concentration equals number of moles divided by volume of the solution. So let's put our values in. As you can see, that means our concentration is 0.25 moles divided by the volume of 0.25 decimeters cubed. So the concentration of the sulfuric acid solution is 1 mole per decimeter cubed. Great work! Let's do one more. What's the mass of potassium nitrate in 500 centimeters cubed of a 1 mole per decimeter cubed solution? First, we need to convert the volume to decimeters cubed. Again, since 1,000 centimeters cubed is 1 decimeter cubed, 500 centimeters cubed is half a decimeter cubed. Now, let's use the triangle. We have the volume and the concentration in moles per decimeter cubed, so we can use the number of moles to work out the mass of potassium nitrate. Covering the N, we can see that the number of moles equals concentration multiplied by volume. Now we can put the values in. The number of moles is the concentration of 1 multiplied by the volume of 0.5. So that's 0.5 moles of potassium nitrate. Now we need to convert the number of moles of potassium nitrate into mass, like the question asks. We need to find the molar mass of potassium nitrate like we've done previously, adding up the appropriate number of relative atomic masses of each element. That gives us 101 grams per mole. Then, remembering from our previous lessons, we know that we can work out the mass in grams by multiplying the number of moles by the molar mass. Putting the values in, this tells us the mass of potassium nitrate is 0.5 moles multiplied by 101 grams per mole, which gives us a final answer of 50.5 grams. These examples illustrate how to use the relationships between concentration, volume, moles, and mass to solve typical GCSE chemistry problems. Great! Let's wrap up. In today's lesson, we delved into the methods for calculating concentration in moles per decimeter cubed. We used the triangle to understand the relationships between concentration, number of moles, and volume of solution, and how to rearrange to find any of the 3 quantities. Through several examples and practice problems, we applied these calculations to different scenarios, reinforcing our understanding of the relationships between volume, concentration, moles, and mass. You should now be confident in using the concentration formula to determine the amount in moles or mass of solute in a solution. In the next 2 lessons, we will further build on those skills to master even more complex scenarios.